All right, let's look at one more situation where we're looking at a real-life graph. We're identifying the important features and talking about them. All right, this one will be about rabbits. I'm sure you've heard the phrase breed like rabbits before. Now, this comes from the fact that rabbits breed like crazy. Consider this. If you start with 2 rabbits, then every year they'll have about 30 babies. Okay, and then if you think about that, those babies mature quite rapidly. Within a year, they're going to be able to have babies as well, which means you're going to be having babies out the wazoo. You're going to have lots of little baby rabbits, which they're cute, but that would be a lot of rabbits. I don't care how cute they are. Within a couple years, you're going to have way too many rabbits to deal with. So what we're going to do is approximate the total number of rabbits, which is based off of this equation. So this is a different situation. This is not this situation with 2 rabbits at 30 babies a year. This is just a relationship for a specific situation. All right. So R is the number of rabbits. T is the number of years that have passed. Okay. The graph representing this function is shown here on the right-hand side. Now we're going to answer the questions. What type of function is this? Okay, now we look at it and we say, okay, well, it could be, well, it definitely could not be linear, and it could not be absolute value, because those both have straight lines. So it's either quadratic or exponential. Now, if I think about it, okay, the graph comes down like this, and the temptation is to right away say exponential, because that's what you see, but, well, could it go back up the other way? Well, it could be a quadratic for which we're only seeing half of it. All right, but if we look at the equation, where is the variable? The variable is the exponent, and that tells us that it is exponential. Okay. Another thing that shows us that it's exponential is because it's so flat down here and it's so steep up here. And that's another clue as to the fact that it's an exponential graph. All right, the next question is, what is the y-intercept? So the y-intercept, I go down here. Oh my goodness, I cannot see where that is. Now, you could guess that if you wanted. A better way of doing it is to say, okay, the y-intercept occurs here at the y-axis when x is 0. So x, which is the number of years, so that's time. So I'm going to say that time is 0. So I'm going to put time 0 in there. And so I'm going to go r equals 30 to the 0 power plus 2. Anything to the 0 power is not 0. It's 1. And 1 plus 2 is 3. So that means that my y-intercept is 0, 3. What does that mean? That at the beginning, right? You could say time is 0, but we're trying to interpret here. So time 0 is the beginning. So at the beginning, there were, and what does y represent? The number of rabbits. So there were 3 rabbits. Okay. Note that in the graph there is no x-intercept. What does that mean? Well, keep in mind that the x-intercept is the place when y is 0. So y is 0, and in this case y is the number of rabbits. So if there's no x-intercept, that means there is no place where there are no rabbits. So there were never 0 rabbits. That's all it means, right? Because the x-intercept is when y is 0, and so therefore, since there's no x-intercept, y will never be 0, and y represents the number of rabbits. So never 0 rabbits. Okay, now this is a new question. This isn't on your worksheet, but it's a good question for you anyway. Does this function have an asymptote or vertex? Well, it's exponential, which means it does not have a vertex, but it does have an asymptote. Okay, identify it. So the asymptote, this is where it's going to get a little bit difficult, because how far do we know down, how far down does it go? Well, you could start plugging in some numbers. You could put in -1, -2, -3 for t and see what you're getting closer and closer and closer to. Okay, another way to think about it is, okay, if I've got r equals 30 to the t plus 2, okay, I want to see what happens when I go way out here to the left, right? What's going to happen when t is a very, very negative number? Understanding that in this situation t can't be negative, but for the line, if it goes out here, what if t was really negative? So let's just make up a number. Let's just say t is -100. Okay, so 30 to the negative 100. What do we do when there's a negative exponent? Well, we rewrite it. 1 over 30 to the 100 power. Now, what is 1 over 30 to the 100 power? I don't know either. And I know that's what you're thinking. You expect me to go 30 times 30 times 30 times 30 times? No, I expect you to stop that now. So, no, it's not, you don't have to work it out. Just know this on the bottom is going to be a really, really, really big number. What's going to happen if I take 1 and divide it by a really, really big number? The result is going to be something really, really tiny. So what are we getting close to? 2 plus something tiny, or in other words, we're getting really, really close to 2. So the asymptote is this horizontal line at y equals 2. What does it mean? It means that there can't be 2 rabbits, because the line won't ever reach that, right? It'll get closer and closer to it, but there weren't actually ever 2 rabbits. In fact, we already knew that because at time 0, there were 3 rabbits. The left-hand side of this graph doesn't really matter at all. If we wanted to talk about domain and range, we could say, okay, domain is where t can be everything down to 0, so it goes to the left. And then if we go to the right, it just keeps on going and going and going and going and going. So as far as we're concerned, because of this arrow, t can be anything greater than or equal to 0, right? Because 0 is the lowest it can be. T needs to be anything larger than that. Okay, if we want to look at range, well, the lowest it goes on my graph is 0, 3. So 3 is the lowest. And then it goes up, 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 up. And it's just as long as time keeps going, r is going to keep going up as well. And so r needs to be bigger than or equal to 3. Or you could write it this way, r is greater than or equal to 3. All right, so that's looking at those ideas for you as well. Again, I know that was not on the worksheet, but hey, we're in the job of learning here, so hopefully that will be helpful to you as you start to look at some of the other questions. All right, get to work.